The Folgertech FT6. Not a bad printer, a pretty good shelf, but mine is going to need just a bit of help. Hello everyone, Chris here, and yes, my Folgertech FT6 is a bit of a mess. But I have a project coming up where I need to do some larger prints, so I need to get it back up and running. Now the last time I tried to use it, I was experiencing some sort of heat creep in the barrel. And when you get your FT6, it's kind of a bare bones machine. So I have made a few upgrades to it already, but when you do really large prints like the FT6 is capable of, you need it to be as reliable as possible. So I thought this would be a great time to go ahead and upgrade the Hotend and extruder setup with something a little more manageable and something I know that's going to be really consistent. So let's start by taking a look at the Hotend extruder setup that I'm going to upgrade to. I've decided to convert the FT6 over to the Bondtech Mosquito setup. Now this is the Bondtech BMG that has a direct port for the Mosquito. It's just got two screw holes in the bottom. I bought this setup a long time ago. I have tested it out on a few different printers, but not for very long. So I want to put it on the FT6 because I know the extruder and the Hotend will both be very reliable for any type of filament that I want to use. And again, when you do these prints that might take several days, you don't want the extruder or the Hotend to be the weak point. And with this combination, I should just be able to install it and forget about the whole thing. This should work for many, many years going forward. And the Mosquito, even the standard model, is capable of a pretty high output. So if I wanted to switch the nozzle out to a larger bore down the road, I could print taller layer heights and speed up my prints if I needed to. So I think it's a solid choice. And I know the combination with the BMG and the Mosquito is pretty pricey. But again, when you're doing a project like this and you want to print large things, you don't want there to be weak points because you're just going to introduce failure. So the hardest part of this whole operation is cleaning off the FT6. I have been storing a lot of different things on it. So let's get that done. Also, this is going to be a really interesting video to record because the printer is so large, I can't record it here on the table. So we're going to have to record it over there on the floor where it sets. So let's get started by taking a few boxes off of this thing. And I only found 5 benchies during that process. That's pretty good for me. So let's start by taking a look at the modifications that I've already made to the FT6 since the last time you saw it. Again, it's kind of a bare bones kit, so I had to add part cooling, I did make the bed stationary, and I added auto bed leveling, as well as a few other things. So let's just take a look around. So here's what we're dealing with in the stock configuration. This is just a Mark 8 style extruder. The extruder arm, the housing, and everything is plastic. We've just got that typical brass gear that you see on a lot of printers. The motor is actually mounted from the back. They replaced 2 of the stepper screws to allow it to mount on one of these plates. It's actually mounted on the back plate over here. So the swap out for our extruder setup and Mosquito should be pretty straightforward. The only thing we really have to figure out is I did put an inductive sensor on this guy. Because the bed leveling for this, the bed is so large and the sheet isn't very thick, it's actually pretty difficult to do. So that sensor definitely helps make prints more consistent. So we want to keep that feature. Also, the FT6 doesn't come with any part cooling. So I did grab one of these fan coolers and put a blower fan on it. So that's something we definitely have to work into our design as well when we convert over to the Mosquito and the Bondtech extruder. So we probably have some work to do on some parts. Another good side to the FT6 is there's a lot of FT5 parts out there, and most of those are compatible with this as well. They're pretty close to the same carriage style. This is a 24 volt system. It does come with a cartridge style thermistor. It's a little bit smaller than you'd usually see. I don't know if you can see that, but we can probably still work with that on the Mosquito. If not, we'll just switch out to a different thermistor. No big deal. This one does have a 40-40 Hotend fan, and we're going to switch to that 25 that goes on the Mosquito, of course. One other thing that I want to deal with, it's all the way over here, it's probably hard to see, are the Endstops and how they're treated on this printer. It actually hits the Endstop so hard that it bends it up. It'd be a lot better if these were stationary. Maybe we'll switch out to some sort of the PCB Endstop, the one that's on the board. We'll tie it down, build a mount. That's going to help its consistency a lot as well. So I want to upgrade that. And the only other thing I've really done to this one is make the bed stationary. So when you get this printer, it comes with a bunch of thumb screws, and there's springs in between the bed and the carriage so that you can level it. But it doesn't work really well on this long bed. So all I did was put a PETG spacer in here, remove the spring, and tighten the thumb screws down. That way, auto bed leveling takes care of the rest. And it actually does work pretty well. The firmware config on this whole thing is actually somewhat challenging, but we're going to go through all that as well because I need to upgrade to the newer version. This one is getting pretty old. So we have some work to do. So as far as this stock extruder goes, I'm just going to remove the arm. And I'll pull my sensor mount off. I just made this one to sandwich around the motor. We're definitely going to have to rework that to fit the new design. Then we can pull this plastic plate off. We're going to use the motor. Now this is actually a pretty tall motor for something like a BMG. You can usually get away from it with a pancake on these. But since it's already mounted, I don't want to rework it if I don't have to. So we're just going to go ahead and use this one and mount our BMG on it. I don't really intend to do a lot of high speed on this, so I'm not really worried about the weight. It should be just fine. We'll lower the current down though, because that's probably a great idea if you have something that is 3-to-1, 5-to-1 that's being reduced. You don't want to crank the current up too high, you might strip something. Here's a look at the hot end and heater block setup you get on this. It's just a barrel and a piece of aluminum, pretty typical for a Mark 8 style. This one was extremely frustrating. Again, I do believe it was heat creep that was causing me all these problems, but it was leaky. I'd crashed it a few times. It's just time to get rid of this and go to something new. Now it's time to go ahead and put the Bondtech gear on. This is what drives the whole thing. The blunt side goes out, sharp side goes in. It's kind of tapered towards the front. And whatever motor you're putting this on, the keyed part of the shaft, make sure the shoulder back here towards the base of the motor isn't deep enough to bother this gear. You need it to go all the way on here and to the motor and leave a gap of about 1 millimeter, 1.5 millimeters. If you don't get it far enough back, it's not going to engage that gear inside the extruder like it should. So there's that, and then we can go ahead and test fit our Bondtech Hotend setup. And before you put your extruder setup on, you might want to go ahead and load your heater and your thermistor, because depending on how your wires are, it might be kind of a tight fit. I was able to use the stock heater, and the stock thermistor did fit, but I'm going to go ahead and swap it out because you don't want any problems with your thermistor. I just swapped in an E3D style. All of the cables for these, all the plugs, are right on the back of the extruder housing in a PCB, so they're pretty easy to reroute. So we'll just go ahead and test fit our extruder here. It should just slide right on. And the Bondtech connects with 3 M3 by 35 millimeter screws. We're going to go ahead and put the top one in, and then we'll talk about those bottom two. These just screw right into that NEMA 17 motor mount. Now this carriage setup doesn't give you a whole lot of options for mounting things. I liked the part fan duct that I had on here before. It's a really good design, but it was made to go on the front of that 4040 fan. So what I elected to do was change up that fan and just put a plate on it, and then I can mount it in those 2 bottom screw holes of the Bondtech extruder. I made this plate so that it would take up a bit of the gap so I could use a longer screw. So I'm going to go with M3 by 40s. With the way I designed the fan, that should be a good fit to go all the way through here and mount into that motor. I don't want to do that quite yet because I want to get everything situated. I'll put this on last. I still do have to put a nozzle on and reroute some of the wires. So that's what we're going to do with that. And now I want to go ahead and test the reworked mount for the probe that I did. The new setup with the extruder is actually a little bit closer to this carriage. So I just redid the probe mount that I had before and made it a little thinner. It still just sandwiches around that NEMA 17. So the new slimmer probe mount seems to work okay. I'll leave links to all this in the description, of course. If you're going to make a probe mount, just make sure the probe is completely vertical. You don't want it leaning one side or the other, because that's going to drastically affect how it senses the bed level. That's not going to do you any good. But this one seems to be okay. We'll field test it for sure, but I think it's going to be alright for now. So I go ahead and put the probe back in. We will have to adjust that probe, so I'll just leave it there for now. Then I can go ahead and clean up my wires. I need to plug in my new thermistor. I'm just going to leave this clip on so I can change it easier later. And they just hook around the back here. So we've got the heater, thermistor, probe, everything taken care of. Hotend fan is on. I just swapped out that 4040 and spliced this one in. Now all we have to do is go ahead and mount our duct onto those bottom two screws. Again, I'm using M3x40s, and then we can put our blower fan on top. So I'm just holding that blower fan in with an M3x25. You might want to go ahead and put just a little bit of glue or sealer back here, because it does occasionally like to jump out of there, but most of the time it's a pretty good mount. So the hardware changes are pretty much done. All I need to do now is a cleanup, because this thing's a mess from the last print that I tried. Pick up a few screws, clean the build surface off, then we'll do a test. I will also need roughly a dozen zip ties to clean this all up. I also do still want to take a look at this Endstop over here and see if there's something that we can do. So here's the PCB that lives over there on the left-hand side of the X carriage, actually the back of the printer. It actually sits more like this. This is your Y Endstop and this is your X. But it's just sitting on the solder joints of those micro switches. So as it starts to bump it, it actually lifts it back because it's flexible in these joints right here. So my idea is I'm going to pull these out. I'm going to pull the switches and at least get the switch in front of this PCB so that when it contacts the switch, it will push it into the PCB that's actually tied down. Then I'm going to try to make some clips that'll go over these. Maybe we just glue them in place, but just something to keep it down and also give it a little bit more impact area here in the front on both of these. So we'll see what we can do. So after some effort, I was able to move the switches out to the front. That already made them quite a bit more stable. I still probably don't want to stick with this whole configuration with this PCB forever if I'm going to use this printer a lot. But I am going to go ahead and make some clips just to make it a little bit more stable than it is now. Hopefully that'll last for at least a while. So I just worked up these two printed cover pieces to go over the Endstop switch. The switch does actually stick out the front of these a little bit, but I just made this so it would give us more surface on the PCB, so when it does collide, it'll keep the switch from wanting to pop up like it was before when it was just on those soldered leads. This isn't a fix-all, but I thought it might give us just a little bit more mileage out of this PCB before we have to do something else. I am just going to hot glue these on there so they'll be somewhat fixed. So we'll see how it goes. So I've got our new Endstop set up over here. It does collide successfully on both sides. Hopefully that will help it stay put a bit. Now I'm going to go ahead and power up. We need to get a nozzle in there so that I can adjust the bed probe so it doesn't collide. So that's the next step. So we're up to temp. I'm going to go ahead and give it a torque. One good thing about the Mosquito, you can usually do it single-handed. Now I'm going to go ahead and put the screw and the nut in place to lock that probe in, but I'm going to bring the bed up, set the nozzle on the bed, put a zip tie into the probe, and that'll be our starting distance. Probe is about a zip strip height away from the bed, nozzle's on the bed. I'm comfortable now, we can go ahead and auto home. Let's see how our new Endstops do. Y looks good, or X looks good. I always get confused. Y? Let's see if our probe's working. And it looks like we are. So I'm pretty satisfied with the current config. We've got the new extruder on, the new Hotend. We fixed the Endstop up a little bit. We'll see how that rides. But this is definitely going to be a lot better Hotend extruder setup for this machine. Now the tricky part. The firmware on this is 1.1.9. So we're going to have to get up to date here. So overall, I'm pretty happy with the modifications we made. Now, it probably didn't seem like it, but creating just those handful of parts and trying to decide how to fix certain issues, that was actually quite a bit of work. It took me a couple of days. And these aren't really upgrades to increase our print quality much, it's just to increase the consistency and overall reliability of the machine. When you have a machine this size, like I said before, you're going to do really long prints, so you want something that you know is going to work. You don't want a lot of failures, that just causes waste. Now, I said before, this machine is currently running 1.1.9. It is a custom config I did a long time ago, but we're well overdue for an update. So that's what we're going to jump into now. So today we're going to be working with Marlin 2.0.7.3. That's the newest one that's out there right now. Again, I'm coming from a really old version, so I'm just going to update it manually. We'll walk through this. I'm not going to hit everything, but most of the stuff that you need to be able to make your FT6 work. I'm also going to try to submit this as a Marlin example out there in the config files on the GitHub, because there isn't one currently. So I'll do one for ABL and then one for a standard model. So we're going to start with configuration.h, and we're just going to scroll on through and set some of this up. My current configuration does have the old school maker-based MKS 1.3 board on it. That will probably be the next upgrade if I want to continue, because that's a pretty old school board. Plus, we could take care of that Endstop issue if we got cincherless homing set up correctly. But that's for another day. Also, if you need an in-depth walkthrough about VS Code, how to get Marlin set up from scratch, all that stuff start to finish, I am planning on doing another video just like that in the very near future, so stay tuned for that if you have more questions. Here we go. So I'll update the config. This is the FT6 ABL by me. And I like to put the date in there. For the 8-bit board, we're going to leave that serial 0. That's fine by default. 250,000 baud rate is good. Motherboard, we do need to change that up. If you want to know the name of the board, you can expand source, core, boards.h, and look for your board. This one is a ramps type of board. It should be in the second part of the file here. We're working with the MKS Gen 1.3. So we'll copy that line, head back to configuration.h, and we'll paste it in right here. We only have the single extruder model, of course 175 filament. Most of this stuff is all for dual nozzles, so we won't need it. We'll continue on. Thermal settings, we did change up the thermistor for the hot end. It is now a number 5 because we switched to an E3D. So we'll change from 1 to 5. The bed sensor is still a 1. We do now have a Mosquito Hotend. I'm going to lower the bed max temp to 130 because it'll never get that high. 275 on the hot end is totally fine. You have a Mosquito now, you can go as high as you want pretty much, up to 400C and some change. I'll leave mine at 275. I don't plan on doing anything over polycarbonate on this printer, even if that. PID settings, we'll need to calibrate that. We do have a new hot end and thermistor. We'll come back to that. I do want to uncomment PID temp bed because I do intend to use PID tuning on the bed. It does turn out a better print in some instances, but we will need to auto-tune that as well and come back and plug in the values. We are homing in the minimum, so we'll leave all this the same. For a minimum Endstop, this type of switch, we're going to make inverting true for X and for Y. Z will leave false. We're using a probe. That's just how those probes work. We can always come back in and tweak it if we need to. Next, we currently do have A4988s for all of these drivers. Marlin does default to the A4988, but it never hurts to update your documentation. So we'll just take the comment off of these 4 lines. And in the movement settings, X and Y on this printer are 80. We're using 4 start lead screws, but the 2 lead screws are tied together with a belt. So that actually increases the number of steps you have to turn those lead screws. The gear underneath is actually just a little bit larger. The setting I use is 720. And then for the original extruder, you would use 95. As a starting point for a BMG, I use 415. That always needs to be calibrated after the fact. Feed rates, I'm going to leave at default for now, as well as acceleration. We can always come back and tune that later. That actually takes a little bit of effort to tune. Plus, nowadays I use a lot of these codes in my slicer, so I set them in the G code anyway. For default acceleration, this is during print moves. I am going to lower this to 2000. Retraction to 1500. And travel to 2000. It's a big machine. You're moving around quite a bit of weight, so we'll slow down a bit. By default now, junction deviation is enabled. It's set to a 0.13. That has to be tuned as well, but this is a good default setting. We'll leave it there. And then we come to the probe settings. Our probe is using the Z-min Endstop pins, and that's the default setting. We'll leave that. It is a fixed mounted probe. We'll take the comment off of that line. And now we need to adjust the probe offsets. And this can be just a little bit confusing because the bed is flipped over. They do give you this map right here to try to tell you what those offsets are going to be. But still, I think it needs to be gone over just a little bit so you understand it. Now, this is based on the probe mount that you're using. You can see anything in front of the nozzle is negative, to the left is negative, back and right are positive. So if we take a look at the FT6, this is actually the front of the printer, this is the back. We're actually homing in the back right corner. So basically, if you flip this whole thing 180, it'd be just a standard Cartesian. But the probe location really doesn't work that way. You have to think of it as X negative this way, because you've gone past 0, and Y negative this way, past 0. 0, 0 is over here. So the probe location is right here. It is negative 30 in the X, so the nozzle's over here, probe's over here. But it's positive 30 in the Y, because the probe is actually inset on the bed 30 millimeters. So we're going in the positive direction. So our offset is going to be negative 30, and then for Y, positive 30. The Z offset, we will calibrate that in a moment. I like to do that with baby stepping. I'll show you how to do that here in a second. Probe margin, again, if we take a look at the FT6, all around here, there's lots of screws close to the edge of the bed. I like to avoid those, so I make the margin just a little bit bigger. For the FT6, I set mine to 35. I also increase the probing speed because it does take a long time to level this bed. I think default is 130. I set mine to 300 times 60. I do like to use multiple probes and an extra probe, so I do 2 multiple probes and then 1 extra. That way it'll work the math out. If there's one that's a little bit off, it will disregard it. Again, it makes the bed leveling take a really long time, but it's worth it with a bed this long. Again, that bed plate isn't very thick. Next thing we come to is stepper direction. The defaults are going to be okay. X is going to be false, Y is true, Z is false, but by default, E is actually set to false. Since we installed the BMG, it's going to turn the opposite direction. Set that to true. Home dir, those are all going to be -1 because we're homing in the minimum, so that's fine. And then another really crucial setting is bed size. So bed size determines quite a few things in Marlin. What the probe map is going to look like, and this is how you get to the center of the bed. You always want to print in the center so you can maximize the volume. And again, with the FT6, we are actually a little bit into X and Y when we home at 0, 0. We're not to the edge of the bed like on a lot of Cartesian machines. So you have to account for that, and there's a couple of ways to do it. Because you can imagine, if you're not at 0, 0, it's going to go further into the bed to get to the center. So the method I like to use is actual bed size. This isn't the print volume, not the parts of the bed that you can reach, but the actual physical size of the bed. I think it makes just a little bit more sense. And on the FT6, it's roughly 740 millimeters in the X and 356 in the Y. Now you can use minimum positions to correct this. So if I set this to like 40 millimeters, it's going to assume that the minimum is 40 millimeters into the bed and try to correct that issue that we have on the FT6. But That's not the best way, and I'll show you why. From here, Z max position, we can go ahead and set that to 400 because we know that's going to be correct. Let's move on. Filament runout, we don't have that. I don't have a sensor on it right now, so I'll just leave that commented out. And then we get to bed leveling. And I'm just going to use bilinear, so I'll take the comment off of this line. By default, it is 3 grid points. I like to do multiples, especially on a bed this big, so I like to set mine to 7. It takes a while, again, because we're doing multiple probes, but it's almost mandatory with this configuration. Manual home position is where I like to correct that issue where we're actually setting inside the bed just a bit. This is what will allow you to get to the center of the bed when you start your print. So if you were outside of the bed, you'd set this to a negative number. If you're inside, you set it to a positive. So these are going to be positive values. I'm going to take the comment off of X and Y. And the easiest way for me to configure this is just to get out a tape measure and measure where the center of the bed actually is, the physical bed. So I'll verify the actual bed numbers. We are close to 741 in the X and around 356 in the Y. So we're good there. And we'll just get the calculator out and we'll divide those. So 741 divided by 2, we're 370.5 in the X, and 356 divided by 2, we're 178 in the Y. So I'm just going to mark that location on the bed. And that puts us about right here. Now you don't have to do this, you can work this out in the math, of course, but I think it just makes more sense if we do it this way. Now we're going to power the printer on, cable up USB, and connect up with the pronter face, and we're just going to manually jog the printer so that the nozzle sets on that center mark. And then once you're over that center spot, if you do an M114, that'll show you your location. We are reporting an X321, a Y164.1. So that's definitely not the center math that we figured, because the homing endstops for X and Y are inset quite a bit. So to correct that, we're just going to take our half bed size, so X370.5, and we are going to subtract our current location, 321. So our manual home position is 49.5. So we'll update that in the firmware. 49.5. Again, this is positive, so it's inside the bed. And then our Y, 178, minus our current location, 164.1. 13.9. So that is the easiest way that I know to configure the firmware to make sure that you're going to print in the center all the time. Now remember in your slicer to make the same bed settings. Make sure that the size of the bed is set exactly the same as it is in the firmware, and you should be okay. With this setting set, you shouldn't have to adjust offsets. Moving on to Z-Safe homing. Now I'm going to leave this commented out because I can home in the corner of the bed. The probe can reach the bed from there, so no problem. But it is going to throw an error when we compile. But it's a sanity check error, and I'll show you how to get around that when we get to the compile part. I am going to enable the EEPROM setting so that we can save things in EEPROM with commands if we need to. I'm going to update my filament temps. I like PLA to be around 215 and 60 on the bed, and ABS around 250 and 100 on the bed. I'm not going to do nozzle park this time around. I probably will include it in my final config. That's mostly if you like to run M600. That might be something you want to do on this machine, so I'll set it up for you. I have a lot of videos on how to do this. I'll leave links in the description. Scrolling on down, we definitely want SD support. so we can read from the SD card. I want to reverse my encoder direction because I like to go down through the menus to the right, up to the left. It's just my preference. You can also do those individually with the menus down in these settings here. If you would like to use multiple frequencies for your buzzer, you can uncomment this. If you don't, it assumes you only have a buzzer with one frequency. This one will allow you to do multiple tones. I believe that's how it works. I always uncomment it anyway, just in case I want to use it. And then finally, in configuration.h, we want to enable our controller. This machine has the 12864 screen. It is the Rip Rep Discount Full Graphics Smart Controller. So we should be good there. Now we're going to switch to configuration_adv.h. There's only a couple of things in here I want to do. The first thing being, I have an auto fan pin set for the Hotend fan, so it's not running all the time. I have it plugged into the second extruder, or the D port, on a ramp style board like we have here with this MKS. If you want to see what your pins are, you can always open up the pins file. You can go to Source, Pins, Pin 7, they call it MOSFET D. That is for your second Hotend if you have one. I've got a fan plugged into it. I'm just going to grab the name so I remember. It makes a little bit more sense to me to use the name than it does the number. You can do either one. Back to configuration_adv.h. I'm just going to paste that right in here. So now that one is going to be controlled automatically. It's going to turn on full blast when it hits to 50 degrees. It's a lot nicer than having one sitting around with a fan running all the time. A couple more things in here. The next one is baby stepping. I do like to enable that. This is so I can adjust the Z probe offset with the LCD knob on the fly. You can kind of use it like first layer adjust. So I like to enable double click for baby stepping. You can hit the button twice, it'll come up while the print's going. And since we have a Z probe, I like to uncomment baby stepping Z probe offset. This will adjust the Z offset on the fly. Now it is a good idea if you make an adjustment, note that adjustment, go back and save it in at least EEPROM. So that's always handy. And the next one is right underneath it, Linear Advance. Linear Advance greatly helps this machine. I highly suggest you turn it on. Just uncomment it here. The only setting you really need to be concerned with is the Linear Advance K setting right here. I set those on a per filament basis. So I just leave this one 0 and I set it in the slicer. A great setting for the FT6 is 0.08. And that should work as well with the BMG. You can always calibrate it. I have a Linear Advance video. I'll leave a link. But 0.08 is a great starting setting for this printer. And everything else, I think we're going to leave it as is for right now. We're going to go ahead and compile. And then if we have issues, we can come back and tweak a few things. So let's head to Platform IO icon over here. We are going to find our environment. You can use 2560, Mega 2560, or Rambo, doesn't really matter. And let's hit build and see what errors pop up. It's going to go through and download all the libraries you need. And then we failed. Now, if you see it where you have no such file or directory, sometimes if your computer does things like OneDrive, it's shuffling files around from here to there, things will get lost in VS Code. The easiest way to clean this up, come over here, back to where you hit build, and just hit clean. That's going to get you back to square one, and then just try building again. Now we did try to compile, but we have errors. And you can see the sanity check wants us to enable Z-Safe homing. This is what I was telling you about before. So you can either go enable it, set where you home, or you can comment it out. If you want to comment it out, like I do, we'll go back to the File Explorer. It tells you right here where it's at. It's in INC, sanity check. And you can just do a Control F to find safe homing. And there's a statement right here. If homing Z with probe, it's Cartesian, and Z safe homing is disabled, throw this error. So we're just going to put 2 slashes in front of this line and comment it out. Be careful when doing this. You might need to Z-Safe Home. I know that I don't, so I can comment this error out. Back to the Platform I/O icon. We'll hit build one more time. The build is complete. Now we can go ahead and hit upload. We are cabled up USB. I'm on COM 7. It should know the board that you have if you have it plugged in. It should be able to find it. So just go ahead and hit upload. The upload is complete. Let's go ahead and get into Pronterface and have a look around. So COM 7, 250,000, we'll connect up. The first time through, it's probably going to complain because our EEPROM is different. We did jump a lot of versions, and it does reset it for you. It'll put something on your screen that says you need to initialize EEPROM because there's a mismatch. But just go ahead and reset it anyway. Do an M502. That'll load all the hardcode defaults and the M500 to save it to EEPROM. That way there's no confusion. And let's go ahead and get our auto-tune settings out of the way for PID. So M303, pick the extruder. So heater 0, E0. We'll do C for cycle times. I'm going to do 10 and then set the temp. We're going to go to 10, a nice medium number. We'll let that run. And here's our results. You can enter those with an M301, M301, P 23.69, I 3.32, and then D 42.22. And then just go ahead and save EEPROM, M500. You can check it again with just an M301. And there's our new values. We'll also take that, copy it. We'll head to configuration.h under PID settings. I'm going to comment out the 3 that are on here now. I'm going to paste my new ones in. And I'm just going to leave a note. Mosquito Hotend, stock heater. So that way I'll know going forward. Now we'll go ahead and start the bed auto tune. M303 for the bed, you want to do -1. We'll go ahead and do 10 cycles, but we'll set the temp for 60. And we'll let that run. And the bed's done. We've got our values right here. We'll just copy them. Back to the firmware. Down here, PID bed. Again. We'll just comment out the defaults. Paste in our new values. And these are stock FT6 numbers. And we can update those in EEPROM on the command line for now with an M304. P 64.10, I 12.62, and D 217.03. You can check it with an M304. We're good. Save it to EEPROM, M500. So let's go ahead now and try to G28 home the printer. You'll notice Y did not home. And sometimes with these mini switches, that's pretty common. There can be interference that it makes it think that these are floating. They're not triggered. And there is a feature called Endstop noise threshold. You can take the comment off of that. Sometimes that will help with this condition. You don't want to run this number up any higher than you have to. 2 is the lowest, 7 is the highest. But just start at 2 and see if that fixes it. So we can go ahead and reflash and upload. So after we enabled that feature, let's give it another try, G28. That is looking much better. So that's a trick. I've seen this a lot on the Ender 3 machines. Some of those switches are just kind of noisy, as well as those boards. So take advantage of that feature if you have to. The only other thing I wanted to check before we continue is that the extruder motor was turning the right direction. We did flip it backwards, and it is. So we're good there as well. Now we're ready to set the Z offset. And I mentioned this before probably, but I just like to start a print, and then we use baby stepping from the LCD to run it down to dial it in. So the Z offset is currently set to 0. We can adjust it on the fly. It works a little bit like the Prusa first layer calibration. It does work pretty well. I have good luck with it. So that's what I'm going to do now. I'll show you that process. So I'm just going to use our small bed leveling print for now to get us started. This will give us a good idea of the Z offset. Then we can tweak it on a larger print a little bit later. So we've kicked off our test print. We're getting done with our quick level here. It is a little bit more inside of the screws, which I like to see. But then as soon as the print starts, we can just start rolling down the LCD. We'll double click, go into baby stepping, start rolling it down into the negative until the filament starts to stick. So you can tell we're definitely far away from it right now. Let's roll it down. And it really didn't take a whole lot of cranking, about a -5.5, and we started to stick pretty well. So then we can go ahead and go back into the firmware and update that setting. So for our Z probe offset, we ended up with a -0.55. So we'll update that there. We can tweak it with that baby stepping later if we need to, but this will be a great starting point. And if we head to prodder face, you can do an M851 to look at the offsets. You can see we have the Z -0.55 here. You can also use that M851 to tweak that later if you want to. But this will be a great starting point. So we got the upgrade done. There's the basics about the firmware. Again, I'm going to have this version available for you if you want to use it on your FT6. You can tweak it however you want. I didn't go into a lot of great detail about setting this up. I realize that, but there are a lot of videos about all these subjects that you can use to get all this done. Now I do want to go ahead and do a much larger print just to test the bed surface and see how it goes. I am going to convert over to a 7-point level just to make sure everything's nice and flat. I have a bed leveling test that is much larger. I'll leave that in the description as well. So let's give that a try. And here's the monster we're going to use for our test. Again, it's just pretty much the same level test. I just made it really large so that I could test this bed size. So let's give it a run. So there it is, our Folgertech FT6 upgrade is complete. Now the hardware changes that we did, this is going to make it a lot more consistent going forward. I mentioned the stock kit is very bare bones, it doesn't even have part cooling. So this is going to make things a lot more consistent when we're doing our larger prints. I do have a couple of projects coming up that need that large build volume. Also the firmware update. All the features that are available in the newer Marlin versions are going to make things a lot better as well. And I will leave all that information for you if you want to give it a try. Hopefully you found this video helpful. That's it for today, and I'll see you on the next one.